Good day, everyone. Here we are at EE 323 Renewable Energy Sources. Presenting to you our group name, the Uncanny Counter from BSEE 3A. My name is Karen Joy B. SERAFICA as a hustler, Tom A. Castillo as a hacker, DEZYLYN G. MATEO as a hipster. So, to fire up our discussion, you can see a generator. We all know that generator produces electricity. So, di ba ito yung ginagamit natin pag walang power sa area natin? So, now, how does generator works? Or paano nga ba siya nag-generate or nagpo-produce ng electricity? And here's some parts of DC generator. The first one is the frame or yoke, interpole, field windings, shaft. Shaft can be called as rotating shaft or also known as rotor. So sa DC generator, ang shaft natin dito is the armature. Sa AC generator naman, meron siyang magnetic poles and stationary armature. Next is the commutator segments, pole show, armature conductors. So ano nga ba yung armature conductors? It is like a cylindrical shape mounted on the shaft. So, ang function nito is to provide a path of low reluctance to the magnetic flux produced by the field winding. Next is the commutator. Ang function naman nito is to facilitate the collection of current from the armature conductors to convert internally developed alternating EMF to unidirectional DC EMF. So, sa ating rotor or yung rotor mechanism, meron ditong maraming type dito na nagpapaikot. Ano nga ba tawag doon sa nagpapaikot sa ating rotor or yung source nito? Tinatawag itong prime movers. So, kailangan natin ng prime movers to generate electricity. So, ayun yung brief explanation how does generator works and gives electricity.
Let's proceed to renewable energy. Renewable energy come from a source that is not depleted when used to naturally replenish on a human time scale. For example, the sunlight, wind, waves, geothermal heat, and etc. These are the types of renewable energy resources. We have solar energy, wind energy, hydrogen energy, ocean energy, hydro energy, geothermal energy, and the bioenergy. So, what is ocean energy? It is a tidal power or tidal energy is harnessed by converting energy from tides into useful forms of power, mainly electricity using various methods. So, working principle, tidal energy is created using the movement of our tides and oceans, where the intensity of the water from the rise and fall of tides is a form of kinetic energy. Tidal power surrounds gravitational hydropower, which uses the movement of water to push a turbine to generate electricity. It means a tidal energy works via a turbine, and the turbine is connected to a gearbox that turns a generator, creating electricity.
Ngayon, what is the cause of tides? High and low tides are caused by the moon. The moon's gravitational pull generates something called the tidal force. The tidal force causes Earth and its water to bulge out on the side closest to the moon and the side farthest from the moon. These bulges of water are high tides. So, kaya nagkakaroon ng high tides and low tide ay dahil sa moon. Yung gravity ng moon, hinahatak niya yung tubig ng karagatan, kaya lumalalim yung karagatan na nagre-resulta ng high tides. Mapapansin natin dito na yung closest at yung farthest side sa moon ay merong bulge dahil yan sa gravity ng moon. Sa gilid naman, dito naman nangyayari yung low tide dahil flat side yung gilid. Now, how many times does tides occur within a day? Most coastal areas, with some exceptions, experience 2 high tides and 2 low tides every lunar day. unlike a solar day. However, a lunar day is 24 hours and 50 minutes. Because the Earth rotates through two tidal phases every lunar day, coastal areas experience too high and too low every 24 hours and 50 minutes. High tides occur 12 hours and 25 minutes apart. It takes 6 hours and 12.5 minutes for the water at the shore to go from high to low or low to high. So mapapansin natin dito, yung unang high tides, nangyayari siya pag opposite siya ng buwan. Then yung pangalawang high tides naman, nangyayari siya pag nakatapat siya sa buwan. Then yung low tide, nangyayari siya pag nasa gilid siya ng buwan.
If high tides are caused by the gravitational pull of the moon on Earth, why there would be high tides on the side of the Earth opposite to the moon? So bakit nga ba meron pa ring high tides sa position ng opposite to the moon? So here are the answer. Cause and the frequency of tides. The high tides on the side of Earth facing the moon is called the high tide. The high tide caused by the bulge on the opposite side of Earth is called the low high tide. So tinatawag nga daw ito ng the low high tide. A low high tide may be understood as the moon's tidal force putting the plane, not the oceans, towards it. So di ba nga yung tidal nag-an siya? It is a gravitational force exerted on the Earth by the moon. So para mas malinawagan pa tayo sa high tide and low high tide, next natin. On the side facing the moon, the gravitational attraction between the Earth and the moon is strongest on the side of Earth that happens to be facing the moon simply because it is closer. So nakaharap siya sa moon, mas malapit siya sa moon. This attraction causes the water on this near side of Earth to be pulled toward the moon. As gravitational force acts to draw the water closer to the moon, inertia attempts to keep the water in place. But the gravitational force exceeds it, and the water is pulled towards the moon, causing a bulge of water on the near side toward the moon. So, meron nga gravitational force and inertia. So, dahil mas malapit itong side facing the moon, or the high tide, mas malapit ito sa moon, na dadaig nito ang inertia. So, napupull dito toward the moon, na nagkakos ng bulge of water on the near side towards the moon. Ito na yung sagot sa tanong natin. On the side opposite of the moon. On the opposite side of the Earth or the far side, the gravitational attraction of the moon is less because it is farther away. Here, inertia exceeds the gravitational force and the water tries to keep going in straight line, moving away from the Earth, also forming a bulge. Diba? Meron nga tayo ng inertia and gravitational force. So, dahil yung opposite of the moon ay malayo siya, so ang nangyayari is mas nananaig yung inertia nito kaysa sa gravitational force ng moon. So, dahil sa sobrang lakas ng inertia, nagkukos ito ng low high tide. Gravity and inertia act in opposition on the Earth's ocean, creating tidal bulge on opposite sides of the planet. On the near sides of the Earth, o tinatawag nga natin the side facing the moon, the gravitational force of the moon pulls the ocean's waters towards it, creating one bulge. On the far side naman, or the opposite side, inertia dominates, creating a second bulge. So, para mas maliwanagan tayo, ito yung figure. Kung saan meron tayong tidal bulge due to the gravity, or ito yung the tidal bulge facing to the moon, kung saan mas nananaig yung gravitational force nito rather than inertia. Ito naman is the low high tide naman, tidal bulge due to inertia. So, due to inertia na siya. Mas nanaig yung inertia rather than the gravitational force of the moon. Largest tidal power station. So, meron tayong 1, 2, 3, 4, 5 largest tidal power station. Ang pinakamalaki dito is the Siwa Lake Tidal Power Station. Meron siyang 254 from South Korea noong 2011. Next is the Rance Tidal Power Station. Meron siyang 240 capacity from France noong 1966. The third one is the Annapolis Royal Generating Station. Meron siyang 20 capacity from Canada, and noon siyang 1984. Next is the MARBEN, 6, tapos mula siya sa United Kingdom noong 2017 naman. And last is the Jiangxia Tidal Power Station na meron siyang 3.2 from China noong 1980. Sobrang tagal na nito, hindi pa rin kami pinapanganak. So, here are some example of tidal power station. The Siwa Lake Tidal Power Station.
Now, these are the types of tidal power: tidal stream generator, tidal barrage, and tidal lagoon. First, what is tidal stream generator? Tidal stream generator is very similar to wind turbines, except they are below the water surface instead of above or on land. The water's current pushes the blades of the turbine, which is connected to a generator that creates electricity. Tidal stream generator is able to produce much more electricity than wind power plants, mainly because water is much denser than air. However, water's high density also means that the tidal turbines need to be much stronger than wind turbines, making them more expensive to manufacture. Tidal stream generator turbines are large, but they create relatively little distribution to the ecosystem around them as compared to tidal barrage. The world's first tidal stream generator was constructed in 2007 at Strangford Lough in Northern Ireland. So yung tidal stream generator is similar siya sa wind turbines. Yun nga lang, sa wind turbines, kailangan mo ng igip ng hangin para mapaikot yung turbines na siya mag-generate ng electricity. Samantalang sa may tidal stream generator, kailangan mo ng agos ng tubig para mapaikot mo yung turbine para maka-generate ng electricity. Ang advantage ng tidal stream generator sa wind power plants is nakakapag-produce siya ng much more electricity kasi yung water is much denser than air. Yun nga lang, mas mahal to kaysa sa wind turbines kasi nga yung water is much denser than air, kaya kailangan mas stronger to kaysa sa wind turbines. So, ito yung tidal stream generator. So, makikita natin, para mapaikot natin yung turbine is kailangan natin ng agos ng tubig para makapag-generate siya ng electricity. So, here's the type of turbines used in tidal stream generator. So, una yung watt o yung horizontal axis wind turbine. Ito yung pinaka-common na ginagamit. Then, yung pangalawa is yung watt o yung vertical axis wind turbine. So, ito yung kanina nabanggit na unang ginawang tidal stream generator sa mundo. Ito yung Sigan Tidal Energy Generator na matatagpuan sa Ireland.
The next is tidal barrage. Tidal barrage are low-walled dams, usually installed at tidal inlets or estuaries. Similar to traditional hydroelectric dams, sluice gates are used to create a reservoir on one side of the barrage. The barrage is secured to the sea floor, while the top of the barrage is just slightly above where the water level hits during the highest tide. Tidal turbines are located towards the bottom of the barrage, inside a tunnel, which allow water to flow through. Also, tidal barrage look like additional hydropower dams. Turbines located along the bottom of the barrage are turned with the incoming and outgoing tides. During an incoming high tide, water flows over the turbines as the water rises. Then, the water flows back through the turbines as it becomes low tide. The turbines are connected to a generator, which produces the electricity. After a construction phase lasting 5 years, the Rance Tidal Power Station was opened on the 26th November 1966. This was the first power station to take advantage of tidal water flow to produce electricity. Here are the picture of France Tidal Power Station in France. Also, the world's second biggest tidal power station. The facility is located on the estuary of the Rance River in Brittany, France. Second picture is the Siwa Lake Tidal Power Station, or the world's largest tidal power installation that located on South Korea. We can see here the tidal barrage flood generation. So, as the tide turns and starts to come in, the sluice gates are closed and the barrage holds back the rising sea level, creating a difference in height between the levels of water on either side of the barrage dam. The sluice gates to the entrances to the dam's tunnels can either be closed as the seawater rises to allow for a sufficient head of water to develop between the sea level and the basin level before being opened, generating more kinetic energy as the water rushes through, turning the turbines as it passes. The next is the tidal barrage F generation. At low tide, all the sluice and lock gates along the barrage are fully opened, allowing the tidal basin to fill up slowly at a rate determined by the incoming flood tide. At low tide, all the sluice and lock gates along the barrage are fully opened, allowing the tidal basin to fill up slowly at rate determined by the incoming flood tide. When the ocean or sea level feeding the basin reaches its highest point at high tide, all the sluice and lock gates are then closed and trapping the water inside the tidal basin. This reservoir of water may continue to fill up to inland rivers and stream connected to it from the land.
The last type of tidal power is the tidal lagoon. So basahin muna natin. A new tidal energy design option is to construct circular retaining walls embedded with turbines that can capture the potential energy of tides. The created reservoir are similar to those of tidal barrage, except that the location is artificial and does not contain a pre-existing ecosystem. So, sinasabi dito na ang tidal lagoon daw is halos kamukha dun sa tidal barrage. Pero, sa tidal lagoon kasi ay man-made na yung reservoir. Sinasabi nga dito na artificial na, so not natural na. Artificial and does not contain a pre-existing ecosystem. Next is the cancelled tidal lagoon, Swansea Bay in Wales, United Kingdom would have been the final tidal power station of this type once built. So ito nga daw yung final tidal power.
Here's the advantages of tidal energy. First is renewable. Tidal energy is a renewable source of energy, which means the energy doesn't deplete as used. So yung tidal energy is hindi siya naubos. Next is zero carbon emissions. In addition to being a renewable energy source, tidal power stations do not emit greenhouse gases during electricity generations. So hindi siya nakakasama sa environment. Then next is predictable. Tidal currents are highly predictable. Low and high tides follow well-known cycles, making it easier to know when will be produced throughout the day. So, alam natin kung kailan mag-high tide o mag-low tide para malaman natin kung kailan natin bubuksan para maka-generate ng electricity. Then last advantage of tidal energy is high power output. Tidal power plants are able to produce high amount of electricity. One of the main reasons for this is because water is so dense, almost 800 times more dense than air. This means that a tidal turbine will produce substantially more energy than a wind turbine of the same size. So, yung tidal turbine is nakakapag-produce siya ng much more electricity than wind turbine. Doon naman tayo sa disadvantages of tidal energy. So, isa rito yung limited installation sites. In order for a tidal power plant to be built, the potential installation site must meet very specific requirements. First, they need to be located on a coastal line, which limits potential station sites to coastal states. These are additional requirements a potential site must meet. For example, tidal power stations need to be built in places where the difference in height between high and low tide is significant enough to power turbines. This limits the power stations can be installed, making it difficult for tidal power to be implemented rightly. So isa to sa disadvantages ng tidal energy Kasi piling lugar lang yung pwede mong pagtayuan ng power plant na kailangan mong ma-meet yung specific requirements na kinakailangan para mapagana yung turbine.
So, these are the disadvantages of tidal energy. One of the biggest drawbacks to tidal power is the high upfront cost. Tidal energy turbines need to be much sturdier than wind turbines because of the high density of water. Most of the tidal power plants that are currently in operation are made of tidal barrage. The construction of a tidal barrage is extremely expensive. The Rance power plant was expensive to build in its day and took about 20 years to actually pay for itself. This is one of the major reasons the proposed 30 BN Severn barrage has not gone ahead. Also, these are the disadvantages in terms of environmental effects. Tidal barrages disrupt the natural flow of water in and out of estuaries. This can have an effect on marine life, disrupting life cycle and spawning. Underwater turbines have the potential to kill marine life, much like wind turbines kill birds. This concern is valid amongst all tidal power plants, but larger marine life is likely to only be affected by tidal stream generators. In France, since the tidal barrage construction needed to drain the estuary in the initial years after the construction was completed, there were severe impacts to the local environment. However, 10 years later, it was considered that the Rance estuary once again had a rich diversity of aquatic life. After the seawall was built in 1994, pollution built up in the newly created Siwa Lake Reservoir, making its water useless for agriculture. Concentration of perfluorooctane sulfonate measured in Lake Siwa were among the greatest ever measured in the environment.
The future of tidal energy. Tidal energy has the potential to offer all the power we need, eliminating the need for fossil fuel, as stated by CIMAC Atlantis Energy. The tide moves a huge amount of water twice a day. Harnessing it could provide a great deal of energy, around 20% of Britain's need. Dito, maraming laboratory tests and maraming engineers ang nagwo-work for the tidal energy. Ine-explore nila yung tidal energy. However, as tidal technology has only been available for a few decades, many challenges remain. British companies and university are currently developing a new wave of technology supported by grants from £50 million Marine Renewable Deployment Fund. Almost 10 years ago, the Southwest Regional Development Agency installed the Wave Hub, the most technology-sophisticated open-access site for testing offshore renewable technology 16 km off the Cornwall coast. Another company also making a splash in the United Kingdom is the European Marine Energy Centre or EMEC in Orkney. So, di ba, para ma-eliminate nila yung mga disadvantage, ang sagot dito is the technology. Di ba, sa panahon natin ngayon, sobrang dami nang naresolba ng technology natin. So, that's all for today. Thank you for listening.